I'm going to show node autoscaling in a Hypershift cluster with a agent cluster API provider. So first of all, I'm going to create a Openshift cluster and a sister installer in the cluster using dev scripts. We can see the config here. And well, let's just run the make and let the magic happen. Okay, we have them there. Let's set a default storage class and let's allow bare metal hosts to be in any namespaces. Let's install Hypershift. We create an alias because we will be using the latest image. Let's set up some variables to define the namespace that we will be using, the name of the cluster, the name of the inframe. So let's create a namespace for this cluster. Let's create a pool secret that will be used for the inframe. Let's create an inframe to generate an ISO image that will be used to start up all the bare metal hosts. See, okay, the ISO is already available. So we are just replacing the name of the namespace that is set by default here and the inframe name. And now with the bare metal host created, we have to just wait for the ISO to be booted and the agent resources to pop up in the cluster. Let's create a loop here, watching for the agents and getting a little bit more of info. Okay, hosts are already running, so let's just wait for the agents. Meanwhile, we can start creating the Hypershift cluster. It will be a agent type cluster in the namespace that we want. Let's also see that the cluster is being created properly. We can see that some agent is already saying hi. We have all the agents present in the cluster. Let's wait for the Hypershift cluster to create all the control plane pods. Let's double check. So let's get the kube config, merge it with the current one. And let's see if there are pods in this new created cluster. Okay, we can see that here we have pending pods because we don't have any node here. Let's enable autoscaling by editing the node pool and changing the manual number of replicas for autoscaling. Set up max of 4, name of the agents that we have. And now just by setting a minimum, we should see that autoscaling creates the minimum number of nodes that we want. We can see that dev extra worker 1 is already binding. So let's wait for this node to be provisioned. And I think we have everything running in the cluster. Yep. So now let's demonstrate the autoscaling part. Let's create a deployment for Nginx. Let's set up high requests so we can scale up nodes when scaling up this. And well, let's start 30 replicas, for example, of Nginx. We can see that there are many replicas that are pending. They don't have any node assigned. And we can see here that it triggered a scale up. We can see now that 2 nodes are starting. So let's wait for them to be provisioned. So let's see if the nodes are here already. Let's see if we have all the pods of Nginx accommodated properly. You can see that we have them spread in all the nodes. Well, let's span some more. Okay, now we have more spread in the different nodes. So we have seen how these scale up. Let's see how it scales down. Quite unlucky, they are all in the same node. So let's put it to 10. Now they are more even. So we'll have to wait for around 10 minutes, 10-15 minutes until cluster-autoscaler decides that one or more of the nodes can be removed. Let's check at the logs of cluster-autoscaler. Extra worker 0, it's unneeded for 1 minute. So after many minutes that a node is unneeded, cluster-autoscaler will remove it from the cluster. So let's just wait for this to happen. We can see that an agent it's in unbinding pending user action. This is probably because we hit a bug that is in LiveBeard and bare metal controller. So well, I have prepared a workaround here. So we can see that the node has been put back into the pool of known unbound agents, so it's able to be reused. If we check the pods, we can see that they have been well recollocated to the nodes that are running. And that's it with the demo. Thank you.